Let's do a beautiful concept, a very important concept. I've given you a triangle ABC and there's another triangle PQR. We have already learned that when two triangles are similar, what happens? We know that if triangle ABC is similar to triangle PQR, then we have learned that all the three pairs of corresponding sides are in proportion. That means their ratios are equal. That means I'm saying that AB upon PQ is equal to BC upon QR is equal to AC upon PR. This is what we have learned. And we have also learned that all the three pairs of corresponding angles are congruent. That means angle A is congruent to angle P, angle B is congruent to angle Q, and angle C is congruent to angle R. This is what we have learned. So if triangles are similar, these conditions are fulfilled. Same way, the vice versa has to be correct, right? That means I'm saying that if all the three pairs of corresponding sides are in proportion, and if all the three pairs of corresponding angles are congruent, then we can say that the triangles are similar. That means every time when we need to prove two triangles similar, we need to have all these conditions given, all these conditions to be fulfilled. It's not going to be given there, right? So out of all these conditions, even if we have three specific conditions which are fulfilled, we can say that the triangles are similar. And these conditions are called as test. Like we had learned test of congruency, same way now we are learning test of similarity of two triangles. So in order to prove two triangles similar, there are in all three tests of similarity which we are going to learn. One is A test of similarity, the second one is S test of similarity, and the third and the last one is SAS test of similarity. So these are the three tests by which we can prove two triangles are similar. Let's understand the first one, that is A test of similarity. Now from the name itself we understand it is angle test of similarity, right? It's going to be very simple. That means there is nothing here about the sides. So suppose I consider a triangle ABC and another triangle PQR, and in triangle ABC I'm saying that the angles are, angle A is 80, angle B is 40, angle C is 60. And here I'm saying that angle P is 80, angle Q is 40 degree, and angle R is 60 degree. In this case, you can see that both the triangles have to be similar. You know why? Because the shape remains the same. Because angle A, you can see, is congruent to angle P, angle B is congruent to angle Q, and angle C is congruent to angle R. That means the shape remains intact, right? And figures having the same shape but not of the same size are similar. That means we know one thing, that these two triangles have to be similar, right? And that is the test which you're learning. So that means here we are saying that in triangle ABC and triangle PQR, we have angle A congruent to angle P, we have angle B congruent to angle Q, we have angle C congruent to angle R. And because of this, we can say that both the triangles, yes, they are similar to each other, and they are similar to each other by A test of similarity. But there's one very important and a beautiful thing which I want you to think. Suppose what I'm doing is, in both the triangles, I don't give you this angle C and I don't give you the measure of angle R. Okay, that's gone. Now tell me, in triangle ABC, angle A is 80, angle B is 40. So can we find the measure of angle C? 80 plus 40 is 120. So obviously the third angle, the remaining angle, has to be 60 degree by angle sum property of a triangle. Same way, if you look at triangle PQR, angle P is 80, angle Q is 40. That means angle R will also be 60. That means what I'm trying to say is that in two triangles, even if two pairs of corresponding angles are congruent, automatically the third pair of corresponding angle is going to be congruent. That means it is going to be similar. That means the two triangles can be proved similar even if we have only two pair of corresponding angles given congruent. That means even if we don't consider this third pair, still we'll have the triangles to be similar. That means this test, instead of writing it as A test, we can just simply write it as A test of similarity. So that means what we have learned is, in any two triangles, if two pairs of corresponding angles are given congruent, we can easily say both the triangles are similar. Wasn't that easy? The beautiful concept of very important, and most commonly in most of the sums, 90% of the sums, you're going to use A test of similarity to prove the triangles, right? Let's go for the next test, the second test. as we had discussed, is SSS test of similarity. That is side test of similarity. That means it's talking only about the sides. So let's say we consider a triangle here. We have the side here, right? One side 6 centimeter. We consider another side to be 4 and one more side here, right? See now 5 centimeters. So we have constructed that triangle. Same way, now we consider another triangle, right? We take the base as 12 centimeter. We take another side to be 8 centimeter. We take the third side to be 10 centimeter and we form the triangle now, right? So that's the triangle which we have. Look at both the triangles. By looking at them, can you say they are similar? Maybe. Just place it above. Looks like the same shape. Yes, you may say they are similar. That means I may say that yes, triangle ABC and this triangle PQR are similar. But I can't just look and say, right? So how do we determine it? There's no angle here, right? If there were angles, we could have said, yes, they have the same shape. They are similar, right? But there are sides here. What have we learned about sides? Sides, the ratios have to be equal, right? So let's check for the ratios. There are 3 sides given, 3 pairs of corresponding sides given. Let's find the ratios. So let's do the ratio. AB and PQ, they are the corresponding sides. So take their ratio, AB upon PQ. How much is that? 4 by 8. 4 by 8 is 1 by 2. Okay. Next one, BC, its corresponding side is QR. So BC upon QR, that is 6 by 12. That is 1 by 2. And then we take AC upon PR, that is again 5 by 10, that is nothing but 1 by 2. So what did we observe? We observed that all the 3 ratios here are equal, right? So in any 2 triangles, if all the 3 pairs of corresponding sides are in proportion, right? Because their ratios are equal, that is what we are writing in these 2 triangles. AB upon PQ is equal to BC upon QR is equal to AC upon PR. Then in that case, we can say yes, both the triangles, they are similar to each other and they are similar to each other by SSS test of similarity. Easy. Now we have the last test, right, to determine whether 2 triangles are similar, and that is SAS test, the combination of sides and angle. Now it's going to be very simple. Let's understand. Again, we construct one triangle first. So we have taken the base here as 6 centimeter. We have taken an angle on the base there as 40 degree. And we take another side here that to be 4 centimeter, right? And we join the remaining 2 vertices to get the triangle. Now we are going to construct another triangle where the base we are taking as 12 centimeter. The angle there, we have taken the same as 40 degree and we are taking the side to be, its corresponding side here to be 8 centimeter. And now we join the remaining 2 vertices to get the triangle. Observe this triangle and tell me, are they similar? We don't know. We can just check, just place it over and just feel if they are of the same shape. Looks like. That means we may say that this triangle ABC and triangle PQR are similar. But it cannot be maybe. We need to justify, and that's going to be by SAS test. Because now, yeah, there are no all the 3 sides not given. All the 3 angles not given. But what is given? There are 2 pairs of corresponding sides given. So let's find the ratio. For AB, its corresponding side is PQ. So let's find that ratio. AB upon PQ. How much is that? It is 4 by 8. That means it is 1 by 2. The next one, BC, its corresponding side is QR. So it is 6 by 12. That is 1 by 2. You got these ratios to be equal. And if you look here, so that means we can write in this 2 triangle, right, AB upon PQ is equal to BC upon QR. That's given. That's what we got right now. And if you look at the included angle, for AB and BC, the included angle is B, which is 40 degree. For PQ and QR, the included angle is Q, which is 40 degree. The included angles here are congruent. So in any 2 triangles, if 2 pairs of corresponding sides are equal and their included angle, remember their included angle, it has to be the angle between those 2 sides. If they are congruent, we can still say that both the triangles are similar by SAS test of similarity. So these are the 3 tests which we have learned. AA test of similarity, SSS test of similarity, and SAS test of similarity. By using these 3 tests of similarity, we can prove 2 triangles are similar.